Hello. Today's lecture is from the Nelson Physics 12 textbook, page 232, question number 6. There are two objects. One is mass m, another one is mass 3m. And the question is this: m and 3m undergoes a one-dimension collision. And m moves 3 times the speed of 3m. m moves faster. 3m is slower. 3 times the speed. All right. And the question says or let me draw here. m is moving to the right. And 3m but the question doesn't say whether the 3m object moves to the left or to the right. The question doesn't say that. And the question is to ask what happens to their speeds. So the question is asking this: what happens to their speeds after collision, afterwards? They bump each other. Afterwards, what happens to their speed? Okay, this is, let's say this is 3v, and this moves with v, because the question says m moves 3 times the speed of this one. But this one doesn't say, the question doesn't say whether this 3m moves this way or that way. Okay, the question doesn't say. And we want the speed afterwards. Okay. So I can assume this moves with v this way. That's one possibility. And this probably moves v this way. Okay, so I have 2 cases. The question doesn't say very clearly. So first of all, let's try this. Let me try this v is moving to the left. So I will start with momentum. What is the total momentum before collision? And according to conservation of momentum, After collision, their momentum remains the same as the momentum before the collision. So let me find the momentum before the collision. Okay. M, momentum is mv, so m 3v. The momentum of this object is m times 3v. The momentum of this object is 3m times v. But the direction is opposite. Therefore, I have a negative sign. Oh, okay. Mass times speed. Mass times speed. They are opposite direction, so I choose right hand direction to be positive. So positive and this negative. Now you see, this is 3mv. This is also 3mv. Therefore, the total momentum is 0. Before collision, the total momentum is 0. So afterwards, I do not know the speed at all. Okay. Let me see the question. Okay. Afterwards, I do not know the speeds. Let me assume that m moves with v1. So that's afterwards. And 3m moves with v2. Let's assume they both move, after the collision, they both move to the right-hand side. Let's assume that. If the calculation result shows the opposite way, then you will have a negative sign, right? Okay, what's the momentum afterwards? mv1 plus, because I assume they both move to the right hand side, so plus 3mv2. This is the momentum after collision, but the momentum after should equal to the momentum before. Therefore, 0. Before collision, the total momentum is 0. So after collision, the momentum is still 0. I cancel the m. So I have v1 plus 3v2 equals 0. I can rewrite v1 is negative 3v2. That means they move in the opposite direction. And v1 becomes faster. You see, v1 is 3 times v2. So v1 is faster then. Then what is v1? What is v2? Okay. You don't know. Okay, you only know after collision, this moves 3 times faster than this one. But it looks like before collision, it's already 3 times faster than this one, huh? So afterwards, it's still the same? No, it's not possible. After collision, they cannot move toward each other, right? After collision, they cannot move towards each other. So this 3 times afterwards should be this condition now. M, 3m, it will be this is 3 times the velocity here. This is, you can say this is 3v2, and this is just v2. That is the situation after collision. But we still don't know v2. So there is no way to find v2, okay? But one possible answer, very possible answer, is that the v2 is just the original v. That is a very reasonable answer. In other words, before collision, this moves 3v, this moves v, they toward each other. After collision, they bounce back. This moves 3v backwards to the left, and this moves v to the right. That's the most logical answer. But from this analysis, you still don't know what v2 is, okay? But and we have no way to find v2. And what I said is the most logical answer is v2 is just v. This v2 equals the original v. Okay. So this is the situation when before collision they move towards each other. Let me continue with the second situation. Before collision, this moves this way. Okay, that's the second condition, second situation I like to consider. So let's erase this. This velocity, the question only says the velocity of the speed of v is 3 times the speed of 3m. So the second situation I consider v is this way. Okay, same thing. Conservation of momentum. M times the velocity plus, now in this case, I need to use plus because they move in the same direction. And then mass times velocity. So what is the total momentum? 3mv plus 3mv. So that is 6mv. I can cancel the m. So I have this relation, 3v plus 3v equals 6v. Of course, you see this is of course true. Huh? So what I want to remember is that the total momentum is 6 mv. All right? Total momentum is 6 mv. That's what I want to know. Afterwards, I need to assume v1, v2 now. This is similar to the first case. I assume this v1 and I assume this v2. And this is 3m and this is m. So afterwards, the momentum is mv1 plus 3 mv2 equals the original momentum, 6 mv. Okay. This is the original momentum. Okay. Now that's it. That's all I have. And I want to say something. What happens to the speeds afterwards? So that is to say, what happens to what is v1 and what is v2? But then I got stuck. I cannot find v1 and v2, right? It's not possible to find v1 and v2. I have two unknowns, but I have only one equation, so I cannot find it. To find v1 and v2, I need another equation, so that I have two equations, two unknowns, right? I need another equation. But this question got stuck here, so that's it. In other words, I cannot describe the velocity, the speeds after collision. But after this section, the book talks about elastic collision and inelastic collision. Suppose I add a condition that it is elastic collision. I like to add one more word. It is perfectly elastic collision. Suppose this is a condition. This condition is after this section, okay? After this section. So I just add it. So what do we mean by perfectly elastic collision? Which means the kinetic energy before collision is equal to the kinetic energy after the collision. If this condition is applied to this question, then we can find v1, v2, because we have two equations, two unknowns. Let's try that, okay? Let's try that. So the kinetic energy before collision, one half mv squared, 1/2 m3v squared, plus 1/2, that's the kinetic energy, plus 1/2 3m v squared. That's a kinetic energy before collision. Let's work it out. So this is 9/2 m v squared. Correct? 9/2 mv squared. And this is 3/2 mv squared. We can add these together. It's 12/2 mv squared it is equal to 6 mv squared. All right? This is equal to 6 mv squared. Okay. I don't want the fraction, okay? 9 over 2, 3 over 2. I don't want the fraction. So, let's see the total. No, let's leave it there. Let's leave it there. Okay, the second condition is this. This is conservation of momentum. Oh, I haven't got the conservation of energy yet. Conservation of kinetic energy. This is kinetic energy before collision. After collision, it's this. So let me write this. After collision is 1/2 m v1 square plus 1/2 3m v2 square. So what is momentum after the collisions? And it is this should equal to that. After collision, this is the kinetic energy, and this is the kinetic energy before collision. They must equal. Let's multiply 2 to this relation. So I have after collision m v1 square plus 3m v2 square is equal to 6m v square. All right. That's the relation after collision. So I multiply, oh, sorry, it's not 6. I multiply 2, so this becomes 12. Okay. So this is a relation, kinetic energy relation. Or I can simplify, cancel the m, so I have v1 square plus 3v2 square equals 12v square. And that is kinetic energy consideration. And from momentum consideration, I have this. So I have momentum considerations, v1 plus 3v2 equals 6v. All right. So I have these two equations. Two equations, two unknowns, I can find v1, v2. All right. So let me erase something to have more space. Let me leave these two equations. I want to solve. Okay. I can solve v1 and put v1 into here. So let's call this equation 1 and equation 2. From 2, v1 is 6v minus 3v2. And I call this 3. I substitute 3 into 1. Substitute 3 into 1, v1 square, so it's this square. Plus 3v2 square equals 12v squared. Okay. Expand this. Okay. Let me rearrange. Oh, this 9 plus 3 is 12. This is 12v squared. So I rearrange. I have 12v2 squared minus 36 v2 move this to this side. I just rearrange it, okay? Divide by 12. So divide by 12, I get this. So this, I can factor it. So this becomes v2 minus 2v, v2 minus v. Let's check. v2 is v2 squared. 2 v2. 1 v2. I get 3 v2. This times that is 2v squared. So this is my result of factoring, which means v2 equals 2v or v2 equals v. So I have two answers. v2 is 2v or v2 is just v. Okay. I need more space here. Okay. For this case, v2 is 2v. This is v2, and v1, oh, I need v1. v1 is 6v minus 3v2. For this case, v2 is 2v, then it's 6v minus 6v, so it's 0. Okay, this is v equals 0. So m, not moving, 3m is this. That's the situation for this answer. So which means after the collision, this smaller mass stops moving, and the larger mass moves to the right hand side with 2v. This v is the velocity before collision. This v is the value before collision. Yeah. So this is a result by considering perfectly elastic collision, which means the kinetic energy remains constant. Now the second answer is V2 is V. Okay. Second is V2 is V. And what is M? So suppose V2 is V. Then this is 3V. 6V, move this to this 6V minus 3V is still 3V. So V1 equals 3V. So after collision, this one moves faster than that. But that is not possible. After collision, they are together. At the instant they make collision, and this will move faster than this in the same direction. How can this be possible? That's not possible, all right? So this second answer, this answer is not possible. So this is the answer. So we completed this question. Let me see, okay. There is, yeah, it's okay. So we complete this question. We consider two cases. One is initially they move toward each other. The second case is that initially they move in the same direction. And we got an answer, all right? For the first case, when they move together, then after collision, they move apart. In the second case, they move in the same direction. After collision, one stop, the lighter object stops moving, and only the heavier object moves ahead. Okay, that's it. So that's the answer to this question. And the question itself is not very clear because it doesn't say in which direction the two objects move. But we need to consider the two possible cases. Okay, good. Thank you for watching. I'll see you next time.